Alright, so today we're going to be looking at triangles and how to tell the difference between different types of triangles. Now, there's two ways of telling the difference. So, you can tell it either by the sides or by the angles. The angles is where the sides meet, right? Okay. So, we'll start with the equilateral triangle. Now, the way you can tell this triangle is that all the sides are the same, see? And all the angles are the same too, which is also fun to see. So the way to remember this is that equilateral is the same, so equal, all the sides are equal, right? Okay, so now we're going to move on to isosceles triangle. Now isosceles triangles, two of the sides are the same and the other one is different. Now the way to remember this is that isosceles triangles, they have iso, so isolate. One side is isolated, it's by itself, it's not the same as the other two, right? So isosceles isolate, one is different from the other two, okay? And so then scalene triangles, all the sides are different. So none of them are the same, none of the angles are the same. Alright, so that's the way to remember that. So, Justin, tell me what an equilateral triangle is and how do you remember it?
An equilateral triangle is a triangle that has all equal sides. Because it says in the word equilateral, it's equal in...
Good. Very good. Alright, and Brandon, how do you tell if it's an isosceles triangle?
Because both the sides are the same and there's one side that's isolated, so it's different from the rest.
Alright, good. And Connor, and a scalene triangle is?
A scalene triangle is a triangle where every side is different.
Good. So if I had a triangle that, so all these markers are the same size, right? So what kind of triangle would this be?
Equilateral.
Equilateral.
Very good. Alright, so now we're going to go on to the angles, how to tell them from the angles. So the first one we're going to look at is the right triangle. So now the reason it's called a right triangle is because it has a right angle. Right angle meaning a 90-degree angle, like on a square or a rectangle. There's, it's a perfect square. If you stick a piece of paper in the corner, it would fit, right? So that's why it's called a right triangle, because it's got a right angle. Now, a acute triangle, the way to remember this is that all of the angles are smaller than 90 degrees. So you remember this because it's a cute triangle. It's really cute. It's small and it's cute, right? Like a little bunny rabbit. It's small and cute, okay? So that's how you say acute triangle. All the angles are smaller than 90 degrees. Now, an obtuse triangle, all the angles, or one angle, is bigger than 90 degrees, okay? And the other two will be smaller than 90 degrees, but one of them is bigger, okay? So now, oh, yes, Nate.
Is it possible to have a triangle that is both right and obtuse?
No, it's not, because all the angles of a triangle must add up to 180 degrees. So if you have a 90-degree angle here, and another angle that's bigger than 90 degrees, that's over 180 degrees.
Oh.
So, okay. So then, Connor, how do you tell, so tell me again, how do you tell if it's an acute triangle?
If all the angles are smaller than 90 degrees.
Alright, good. Now, Nate, tell me, do you think that you can have an isosceles triangle that is also a right triangle?
Yes.
Yes.
Because it would still have the 90-degree angle with two of the sides that are the same length.
Very good. Yes, you can. Alright, so what we're going to do is we're going to figure out how to remember which variable goes on which axis of the graph on your experiment. So, to remember this, you do dry mix, okay? So there's a little jingle to remember it by, so I'm going to sing it once, and then I want you guys to sing it with me the second time, alright? Okay, so D is dependent, R is reaction, dry goes on the y-axis, mu manipulate, I's independent, mix goes on the x-axis. Alright, you guys got it?
Yes.
Okay.
Yeah.
Okay, so ready?
D is dependent, R is reaction, Y goes on the y-axis. Mu manipulate, I's independent, mix goes on the x-axis.
Hey! Hey!
Woo!